Hello everyone. This is the fifth video in a series of videos going over how to program using the Arduino. In this video, we will be using the Arduino to control an LED light using a potentiometer. A potentiometer, more or less, is nothing different than a variable resistor. So we're going to be changing the value of the resistance in the potentiometer, and when we do that, we're going to get a reading, and we're going to use that reading to control the brightness of the LED light. So let's quickly take a look at my setup here. I've got my Arduino and my breadboard wired up. A few things to point out that you need to take care of. The potentiometer in my setup is plugged into analog pin A0. And it does not have to be an A0, but it does have to be in an analog pin. Similarly, my LED light is plugged into digital pin 9. And it has to be in a digital pin, but it has to specifically be in one of the digital pins that has the little tilde next to it. And so that would be either pin 3, 5, 6, 9, 10, or 11. And then lastly, just like in the previous video with the blinking LED light, I've got a 1000 ohm resistor in series with the LED light. So go ahead and take a few minutes and set up your breadboard and Arduino as I have it here. Okay, now let's go ahead and open up a new sketch. And like always, create your documentation, who it's created by, the date you're creating it, and then a quick blurb about what the program is doing. So again, as a reminder, this program is going to be controlling the brightness of an LED light based on the reading of a potentiometer. So the first thing we need to do is declare a few variables. First, we want to declare variables that are going to store which pins our components are connected to. So first, let's do the pin that the potentiometer is connected to. I'm going to call that pot pin. And again, for me, this is connected to pin A0. And as always, just create a quick comment saying what this line is doing or what it's saying. So the potentiometer is connected to pin A0. And then we also have an LED light. So we're going to create a variable again called LED pin. And for me, it's in pin 9. Again, for you, it could be a different digital pin, but it has to be one of the digital pins with the tilde. And again, we'll add our comment. Okay, and then we're going to need two more variables. One of these variables is going to store the value of the potentiometer reading. And then the other variable is going to store the value that we're going to write to the LED light in order to get a certain brightness. So we'll start with the potentiometer reading. I'm going to call that pot reading. And we're not going to set any value for it right yet. We're just going to add our comment. This variable stores the potentiometer reading. And then similarly, we're going to have an LED brightness variable. Okay. Now within void setup, we have two pins, so we need to do the pin mode. And I must confess here that I think in the blinking light video, I got the input and output mixed up. So an input is when you're writing something to a component, you're sending information to a component. An output is when the component is sending you information back. So I apologize for getting that backwards. It turned out, at least in the blinking light program, that it had no effect on our program, interestingly. But anyway, so first we need to say what kind of pin our LED pin is. Again, since we're writing information to the LED, we're telling it how bright to be. This is going to be an input. And again, that's got to be in all caps. So we're going to set the LED pin to be an input. And then on the flip side of that, our potentiometer pin is going to be an output. We're going to be reading information from the potentiometer. Okay. Now within our void loop, the first thing we want to do is we want to read the value of the potentiometer. So that's what we used, or that's what we declared the integer variable pot reading for. So we're going to say that pot reading, or the potentiometer reading, is equal to, and now since this is an analog pin, we're going to be using analog read. And then all we need to do is tell it which pin to read. So we're going to be reading from the potentiometer pin. So as a comment, we're going to say read the potentiometer pin. And this is going to give us a value, let's see, which gives us a value between 0 and 1023. So the potentiometer reading gives us a value between 0 and 1023. And when we're writing a value to the LED light, it's only going to accept a value between 0 and 255. So somehow we have to take that number that's between 0 and 1023 and convert it to a number that's between 0 and 255. And the way that we're going to do that is using something called the map function. So the map function takes 5 inputs. First, it's going to take the potentiometer reading, and then it's going to take the minimum and maximum values of the number we're giving it, which is the potentiometer reading, and the number we want to get, which is the LED brightness. And to show you a little bit how this works, let me switch over to a different video. We want to take the potentiometer reading, which is between 0 and 1023, and map it to a value between 0 and 255. This gives us the 2 points on this graph, and we can use the point slope formula to draw this line. Then, if we want to know the LED brightness when the potentiometer reading is, say, 200, we simply read it off the graph by following this line, and we can see that it would be 50. Likewise, we can do the same for a potentiometer reading of 800, and then see that the LED brightness is 200. And this is how we would go about mapping the value for the LED brightness for any given potentiometer reading. Okay, so now that we have a good idea of how the LED, or how the map function works, we're going to take that LED brightness value, which again is between 0 and 255, and now we're going to do, this is going to seem confusing, but we're going to do an analog write to the LED pin. And the value we're going to write is the LED brightness. Now this should seem a little bit confusing because the LED pin is in a digital pin. But remember I said it has to specifically be in one of the pins with the tilde. And what the tilde means is that the pin is able to do what's called pulse width modulation. And what that means is effectively that we can analog write to that pin. And so now instead of switching it just to on or off, it's turning it on and off at a specific rate, and it's giving you the effect of an analog signal. So it's almost like cheating. But so we're going to analog write the LED brightness value to that LED pin, and let me not forget my comments. So map the potentiometer reading to 0 to 255. And we're also write the LED brightness to the LED. Alright, and that's it. So let's go ahead and upload this to our code, and we'll take a quick peek at it. Okay, so our code is uploaded to the Arduino. Let's go ahead and take a look at our breadboard. And we can see here, as I'm changing the value of the potentiometer, as I'm turning this knob, the LED light is getting brighter and brighter, and then if I turn it down, it's getting dimmer and dimmer. And so we can see here how we're using an analog signal from the potentiometer to control this LED light. As a challenge for you, I'd like you to combine what we've learned about conditional statements to control the LED light here with the potentiometer, but we're going to control it kind of like a digital signal. So what I want you to do is I want you to say, if the potentiometer reading is greater than, say, 512, then turn the LED light on. And if it's less than 512, turn it off. Go ahead and see if you can use those conditional statements to effectively turn this into a digital signal. So this has been the 5th video in a series of videos going over how to program with the Arduino. I hope you found this video useful, and I look forward to seeing you in the next video.